In this video, we are going to learn about the architecture of the first commercial computers. This architecture is known as von Neumann architecture. Although named after mathematician von Neumann, idea behind this architecture originated with J. Presper Eckert and John Mauchly, who worked on ENIAC. This architecture was designed based on the idea that data and instruction can be stored in same place. This concept is also known as stored program concept. It suggests that data and instruction to manipulate data are same and could be stored at the same place. That means programs can be stored in same memory beside data they work with. This architecture also separates components that process data and the components that store data or instructions. Following components came with the computers that used this architecture: memory unit, arithmetic logic unit, and control unit were combined into one processing unit. Input unit and output unit became separate components as well. Number of bits that can be stored in a single location of memory is named as word or cell. A cell has a specific address in memory. Address of cells starts from 0. If addressability of machine is 8 bits, addressable location will be 2 power 8 is equal to 256. So first location address first address will be 8 zeros, and last location, which is 256th location, will have address of 255 or 8 times 1. Contents of location can be data and instruction. Arithmetic logic unit is for performing arithmetic operation of addition, subtraction, multiplication, and division. And it also performs logical operations such as AND, OR, NOT, NAND, NOR, XOR, and exclusive NOR. Number of bits processed at once by ALU is called word. A word is stored into a single cell of memory. It is also equivalent to number of bits that can be transferred through a bus. Modern processors are single word 16-bit, double word 32-bit, and quad word 64-bit. Temporary storage units called registers, which reside inside ALU, store words of data that are frequently needed for processing. Control unit, as its name suggests, controls transfer of data and instructions. This unit contains two main registers, program counter and instruction register. Program counter holds the address of next instruction to be fetched from memory. Instruction register holds the current instruction which is to be executed by the processor. Control unit is in charge of the fetch, decode, execute cycle. We will learn about this cycle in different video. Control unit is connected to memory by a set of wires called a bus. A bus is used to transfer data between processor and memory. Input and output unit may be built into the computer or can be separate in form of a device. Purpose of input unit is to enter or provide data or instruction to computer for processing. Earlier input devices drilled holes on paper tape or punch cards. Modern input devices are mouse, keyboard, and scanning devices. Output unit is the device which provides result after data is processed or stored in memory to the outside world. Common output devices are printers and displays. All of units on von Neumann architecture, memory, arithmetic logic unit, control unit, I/O devices, are embedded on the printed circuit board called motherboard. Motherboard supports connection to other devices such as input and output and storage devices. Wires called buses connect devices on motherboard. These computers are referred to as n-bit computers or processors. N refers to the size of data bus of the processor or the word length. This was the basics of computer architecture. In next video, we will learn about the fetch, decode, execute cycle of the processor.